alcohols, and this oxidation of the alcohol has two types of oxidizing agent. One was the mild oxidizing agent, another was the um, strong oxidizing agent. Strong oxidizing agent directly convert alcohol into the carboxylic acid, whereas the mild oxidizing agent first convert the given alcohol into aldehyde, and then it convert aldehyde into carboxylic acid. So here are the examples by which we can understand that. Okay, at the same time we should even know that the primary alcohol is converted into aldehyde, whereas the secondary alcohol is converted into ketone. Tertiary alcohol, if we try to oxidize it, it does not oxidize, but if we even forcefully try to oxidize it, it gives us the alkene. So this is what we are going to study, or this is what we have studied yesterday. You can see that butanol with the Jones reagent directly give butanoic acid, but ethanol with CrO3 gives ethanol first, and then this ethanol is converted to ethanoic acid with the CrO3 itself. So CrO3 is a mild oxidizing agent. This is the primary alcohol, so it gives aldehyde. But 2-propanol with the mild oxidizing agent CrO3 gives us 2-propanone, which is a ketone. So primary alcohol gives aldehyde, whereas secondary alcohol gives us the ketone. This is how we study and understand. Uh, Propanol on strong oxidizing agent acidified KMNO4 gives us the propanoic acid. At the same time, the mild oxidizing agent CrO3 convert cyclohexanol into cyclohexanol. So you can easily understand that this is the secondary alcohol. Cyclohexanol is the secondary alcohol. Now today, my dear students, we are going to study about the very important oxidizing agent or the oxidizing reagent. That is what it is known as the PCC. This PCC is a very important and very nice, very specific oxidizing agent. PCC, the full form is pyridinium uh, chlorochromate. PCC is a complex of pyridine, hydrochloric acid, and chromium trioxide. This PCC turns primary alcohol to aldehyde without affecting any unsaturation. So if there is double bond or triple bond present in the compound, PCC does not affect it and just convert this alcohol part into the aldehyde part. You can see that this CH2OH is converted to CHO, rest of the part remains the same. So you can see that but2-ene 1-ol is converted to but2-ene 1-al without any change or without any disturbance to the unsaturation. Same way, if you have hexane 1-ol, it can be easily converted to hexane 1-al with the help of PCC. If you have allyl alcohol, this allyl alcohol can be even easily converted to propanol without affecting this double bond, my dear students. So this is how it is very important. We can even oxidize alcohol into the aldehydes ketones with the help of copper metal. So if we take copper metal and heat it alcohol at 573 Kelvin temperature, this copper in the presence of alcohol at 573 behave as a mild oxidizing agent, and it converts aldehyde into ketone. It converts the alcohol into aldehyde, primary alcohol into aldehyde, and secondary alcohol into ketone. You can easily see from this reaction that RCH2OH is converted to RCHO in the presence of uh, CO oblique 573. Same way you can see here that a secondary alcohol can be easily converted to ketone with the CO oblique 573. Let us do the same. So if you have ethanol and if you heat it with the copper metal at 573 Kelvin temperature, you will get ethanol. If you have 2-propanol and if you heat it with the copper at 573 Kelvin temperature, you will get propanone. So you can see that primary alcohol is converted to aldehyde, whereas secondary alcohol is converted to ketone. Now, my dear students, we can heat the tertiary alcohol also with the CO 573 Kelvin. So we can heat this tertiary alcohol even in the presence of the copper metal at 573 Kelvin. Let us see what happens. You can see here in this reaction that when we have a tertiary alcohol, and if we heat this tertiary alcohol in the presence of copper metal at 573 Kelvin temperature, let us see what happens. You can easily see it here in this reaction that when we heat the tertiary alcohol, you can see here the tertiary alcohol 2-methyl 2-propanol, it is the tertiary alcohol. So when we heat this tertiary alcohol in the presence of copper at 573 Kelvin temperature, we get 2-methyl propene. So instead of oxidizing, here the dehydration takes place and we get alkene as a product. So tertiary alcohol unheated with copper at 573 Kelvin gives us the alkene instead of oxidizing itself. Now, my dear students, we are going to study the biological oxidation of alcohols. Biological oxidation of methanol and ethanol in the body produces corresponding aldehyde followed by the acids. So denatured alcohol now we are going to study. See, in our body or in the body of the living organism, biological oxidation of methanol or ethanol takes place and corresponding aldehydes are produced. So methanol turns into methanol and ethanol turns into ethanol. Now let us study the definition of the denatured alcohol. Denatured alcohol is the alcohol that contains methanol. If denatured alcohol is drunk by human being, it turns to methanol in our body. This methanol in our body is converted into methanol and then to methanoic acid in the body, which may cause blindness, or death. So remember, if we drink denatured alcohol, it may cause blindness or death. Please remember this very well, my dear students, that if we really drink the denatured alcohol, it may cause the blindness or death to us. Now, if a person has drunk the denatured alcohol, what is the treatment? A methanol poisoned patient is treated by giving intravenous. Please remember this word. Intravenous means directly into their veins. Intravenous infusion of diluted ethanol. So, my dear students, these people are given the intravenous infusion. These people who have drunk the methanol, they are immediately given the intravenous diluted ethanol. How they are cured? The enzyme responsible for oxidation of aldehyde to acid is swamped, allowing time for kidneys to excrete methanol. So this methanol, whatever it is being produced, ethanol convert them into the methanoic acid, and this is how our body has got time to excrete the methanol. Our body means kidney. So kidney get time to excrete the methanol. So this is how, my dear students, we truly understand about the how we can treat the patient if he or she has drunk the uh, denatured alcohol. Now, my dear students, we are going to study here the various reactions of phenol. On your screen, you can see that I have explained those reactions of phenol in the same page. So let us try to study the various reactions given by phenol. You can see here that most of the reactions which are given by phenol, they are the electrophilic substitution reaction. So first thing that we need to remember that phenol always give the electrophilic substitution reaction. Let us study each reaction of phenol in detail one by one. So let's have a look at that. Let us first uh, study this point, which is a very important point for us to study, or it is very important to bring it to your notice. No, this is what we are going to study later, but please pay attention that phenols of reactions are mostly the electrophilic substitution reactions. Now we will study the each reaction of phenol one by one. So first we should study the nitration of phenol. So please pay attention, my dear students, that first we are going to study the nitration of phenol. The nitration of phenol is very interesting to learn about, and it will be wonderful to study the nitration of phenol. If you really want to pay attention, please pay attention to this part for a while. See, phenol, when it is allowed to react with the dilute nitric acid, it gives us the orthonitrophenol and para-nitrophenol. Now, you are very much aware that phenol is orthopara directing, and that is why it will give us the orthonitrophenol and para-nitrophenol. Now, there are some speciality of this both orthonitrophenol as well as the para-nitrophenol. This orthonitrophenol has H bond. The para-nitrophenol also shows the H bond. Orthonitrophenol and paranitrophenol can be separated by steam distillation. Why? Because orthonitrophenol is steam volatile due to intermolecular H bond. So now, my dear students, you can see here that our orthonitrophenol has got this kind of intermolecular H bond. You can see here, this is the intermolecular H bond between the nitro group and phenol group. And this is how we can understand that this orthonitrophenol has a intermolecular hydrogen bonding. So you can see here under the orthonitrophenol, I have written intramolecular hydrogen bond. As it has got intramolecular hydrogen bond, it's boiling and it is, steam volatile. As it has got intramolecular hydrogen bond, it is steam volatile. Its boiling point is lower than the paranitrophenol, and that is why by steam distillation, my dear students, we can easily separate the orthonitrophenol with the paranitrophenol, and this orthonitrophenol is separated first because it is having the lower boiling point. Now please pay attention to the next point. The next point is about the paranitrophenol. Paranitrophenol is less volatile because it has intermolecular hydrogen bonding. So the intermolecular hydrogen bonding found into the paranitrophenol can be seen here in this particular figure, my dear students. You can see that here we have the paranitrophenol. This is one paranitrophenol. This is another paranitrophenol. You can see them. And both these paranitrophenol are bonded with this intermolecular hydrogen bond you can see here. So paranitроphenols are bonded with the intermolecular hydrogen bonding, and that is why paranitrophenol has lower boiling point as compared to has higher boiling point as compared to the orthonitrophenol, and that is why orthonitrophenol and paranitrophenol, they can be easily separated by the method, and the method is known as the steam distillation. And here during the process of steam distillation, orthonitrophenol, which is a steam volatile, it comes out first. It is separated first in the form of vapor, whereas the paranitrophenol, which is having the intermolecular hydrogen bond, which has the higher boiling point, it does not come out, and this is how it can be separated. So this is how, my dear students, we understand the difference between the orthonitrophenol and the paranitrophenol. Now, my dear students, we are going to understand again the nitration of phenol in some other manner. So, for preparing picric acid, please pay attention to the box that I make here. The text that is written with the black ink. For preparation of picric acid, phenol is first treated with concentrated sulfuric acid. So phenol 2,4-disulfonic acid is prepared, which gives picric acid with concentrated sulfuric acid. So my dear students, when you look at this reaction, which I am going to show you, the reaction of phenol, here you can see that phenol is treated with concentrated sulfuric acid, and then it is treated with concentrated nitric acid. So we get a yellow substance. The name of this yellow substance is 2,4,6-trinitrophenol or picric acid. Now, in your textbook, my dear students, they have just written this concentrated nitric acid, but they have not mentioned about concentrated sulfuric acid. So please remember this, that for preparing picric acid nowadays, phenol is first treated with, please remember, phenol is first treated with concentrated sulfuric acid, so that by treating it with the concentrated sulfuric acid, the new substance formed, and that new substance has the name phenol 2,4-disulfonic acid, and phenol 2,4-disulfonic acid on treatment with concentrated nitric acid, it gives us 2,4,6 trinitrophenol. This 2,4,6 trinitrophenol is also known as picric acid, and this picric acid is yellow substance, or picric acid is yellow in color. Please remember that 2,4,6-dinitrophenol is known as picric acid, and this picric acid is yellow in color. So now, my dear students, we want to study two very important, or the next process for phenol, and that is what it is known as the bromination of phenol. You can see here that phenol undergoes the bromination by two different methods. The first method is the reaction of phenol with bromine in Br2 in CS2, that bromine in carbon disulfide, or Br2 in CHCl3, that is bromine into the chloroform. So if bromine is dissolved into the carbon disulfide, if bromine is dissolved into the chloroform, and if it is allowed to react with phenol at 273 Kelvin, we can get two different products. First product that we are going to get is orthobromophenol. Second product that we are going to get is parabromophenol. Remember, my dear students, that orthobromophenol would be minor product, would be lesser in quantity as compared to the parabromophenol, which is the major product in this case. So remember, once again, phenol, when it is allowed to react with bromine dissolved in carbon disulfide or bromine dissolves in chloroform, it gives us orthobromophenol and parabromophenol. Orthobromophenol is minor product, parabromophenol is major product. But instead of our phenol dissolved into the, instead of phenol allowed to react with the bromine dissolved in carbon disulfide or bromine dissolved in CH3H3, if we take bromine water, that is simple Br2, then in case of the bromine water, phenol is directly converted to a very important product. That is what it is known as the 2,4,6-tribromophenol. So phenol, when it is allowed to react with the bromine water or Br2 only directly, then it gives us the 2,4,6-tribromophenol. This 2,4,6-tribromophenol precipitates out during the reaction as a white precipitate. At the same time, 3 hydrogen bromide molecules are also produced during this reaction. Now, my dear students, you can see on your screen the new reaction that we are going to study. This reaction is known as the Reimer-Tieman reaction. Please learn and remember this Reimer-Tieman reaction or Reimer-Tieman reaction, whatever they call it. So first, let us study about the Reimer-Tieman reaction with us. Let us pay attention to the Reimer-Tieman reaction. In this reaction, my dear students, we take phenol. In the Reimer-Tieman reaction, my dear students, we take phenol, and phenol is allowed to react with chloroform, that is CHCl3, in the presence of aqueous NaOH. Remember, my dear students, the phenol is allowed to react with the chloroform and aqueous NaOH. When chloroform is allowed to react with these two reagents, we get an intermediate. This intermediate is named benzyl chloride intermediate. You can see here. This benzyl chloride intermediate, on treating with the alkali NaOH, undergoes the process which is known as the hydrolysis. So on hydrolysis, my dear students, we get the another product which is having the substitution of benzaldehyde. And then this intermediate, when it is allowed to when it is treated with the acid, it gives us the product which is known as the salicylaldehyde or salicylaldehyde. So this is how we get the salicylaldehyde from the phenol by these various steps. Once again, you can remember it is very important reaction. Phenol treated with chloroform and aqueous NaOH will give us the intermediate. Then it is hydrolyzed with the NaOH, followed by the treatment with acid will give us the salicylaldehyde very easily. So now let us understand each step in detail, my dear students. You can see here that in this particular step, we first take phenol. This phenol is then treated with, you can see that phenol is treated with chloroform and aqueous NaOH. On treatment with chloroform and aqueous NaOH, my dear students, we get an intermediate which is known as the benzyl intermediate. You can see this benzyl intermediate here easily on your screen. So this benzyl intermediate on treatment with NaOH undergoes the hydrolysis and it gives the sodium salicylaldehyde. You can see here we have benzene and aldehyde and ONA. This ONA turns OH when it is treated with acid H plus. So this ONA simply turns into the OH when it is treated with the H plus, and as this OH with CHO is known as the salicylaldehyde or salicylaldehyde. This is how we call it, and this is how, my dear students, we truly understand the process of Reimer-Tieman reaction. You can easily see the reaction that you can understand here. Phenol, then benzyl chloride, then treatment with sodium hydroxide and acid will give us salicylaldehyde. So this is how, my dear students, we study the Reimer-Tieman reaction. Now, my dear students, we are going to study a very important reaction which is known as the Kolbe's reaction. So let's have a look to this Kolbe's reaction. Here you can see the Kolbe's reaction, my dear students. During the process of the conversion of our phenol into salicylic acid, this Kolbe reaction is used. So Kolbe reaction simply convert phenol into the salicylic acid. In this reaction, phenol is first treated with sodium hydroxide so that we get sodium phenoxide. This is what it is known as the sodium phenoxide. This sodium phenoxide, when treated with the carbon dioxide and acid, it gives us the 2-hydroxybenzoic acid, and this 2-hydroxybenzoic acid is also known as the salicylic acid. It is also known as the orthohydroxybenzoic acid. Once again, my dear students, that this particular, in this Kolbe reaction, phenol is, in this Kolbe reaction, my dear students, phenol is first treated with sodium hydroxide. So we get sodium phenoxide. Sodium phenoxide, when it is treated with carbon dioxide and acid, it gives us the 2-hydroxybenzoic acid. The 2-hydroxybenzoic acid itself is also known as the salicylic acid, and 2-hydroxybenzoic acid, salicylic acid, is also known with the another name which is known as the orthohydroxybenzoic acid. So this is how, my dear students, we can easily understand the process which is known as the Kolbe reaction or Kolbe process. Now, my dear students, we are going to study the reaction of phenols. So now we are going to study the reactions of phenol. Few important reactions of phenol. The first reaction that we are going to study is the oxidation of phenol. So you can see here we are going to study the oxidation of phenol, my dear students. Here the phenol that we have, this phenol is, sorry dear students, here you can see that the phenol is treated with this is for you. You can watch it easily. So I have made it a clear idea for you, my dear students. We want to study this particular reaction. So you pay attention to this only. So here first what happens, this phenol is treated with Na2Cr2O7 sodium chromate in the presence of sulfuric acid. So phenol is oxidized by the sodium chromate in the presence of sulfuric acid, and we get benzoquinone. We get benzoquinone. This benzoquinone is actually the conjugated diketone. Now why they call it conjugated diketone? Because you will see alternate double bond throughout this compound. You can see the double bond is here, but it is not here, and it is not here. But alternatively, after this double bond, there is no double bond, but then you can see both the side, there are double bond. Then again, there is no double bond here. And you can see there is double bond next. So it is conjugated diketone. You can see that there are two keto group here, and that is why it is also known as the diketone. Now a very important text for you, my dear students, that I have written here. What happens to phenol when they are kept open into the air? So please pay attention. In the air, phenols are slowly oxidized. Remember, in the air, phenols are slowly oxidized to a dark color mixture containing quinones. So here we have seen only benzoquinone, but there are few more quinones which are possible, and when we keep the phenol kept open into the air, it gives the dark color mixture of various quinones, and this is how, my dear students, we understand the oxidation of phenol. Now, my dear students, we are going to study the reduction of phenol. So phenol is reduced. How do we reduce phenol? So phenol is reduced with the help of the zinc dust or a zinc metal. So phenol, when it is heated with the zinc dust, it gives us the benzene and zinc oxide. So please remember that phenol, when treated with the zinc dust, it gives us the benzene and zinc oxide. So this is how, my dear students, we can see all the reactions of phenol simultaneously now. You can see on your screen that you have all the reactions of phenol that is present on the screen. Prem, please remove this shed that you have created. Okay. So now you can see all the reactions of phenol in the same page, that we can easily revise and study it well. You must have seen that we have studied all the reactions. We have studied the nitration, we have studied bromination, that is also known as halogenation. We have studied Reimer-Tieman reaction, we have studied Kolbe reaction, we have studied the oxidation of phenol, and then we have studied the reduction of phenol, which is, and all these reactions are nothing but the electrophilic substitution reactions of phenol. So I hope, my dear students, you have understood everything. If you have any doubt, you can ask me. My dear students, if you could not understand anything, बच्चों अगर आपको कुछ समझ में नहीं आ रहा है तो आप लोग मुझसे पूछ सकते हैं. बच्चों, हेलो, क्या आप मुझे सुन पा रहे हैं?
Yes, sir.
Yes, sir.
Yes, sir.
समझ में नहीं आया तो पूछ सकते हैं. सब समझ में आ गया?
Yes, sir.
Okay. चलिए, then we move to the next topic. The next topic is some commercially important alcohols. This year CBSE has omitted this topic, but we are not aware with like when they ask any question from this. So let us study this. Some commercially important alcohols. The first one is methanol. Methanol is known as wood spirit. Methanol is known as wood spirit, and methanol was produced by destructive distillation of wood. Now, why did I write was here? Because this is the method which was used in past. Nowadays, most of the methanol is produced by the catalytic hydrogenation of carbon monoxide at high pressure and temperature, and in the presence of ZnOCrO3 catalyst. So you can easily understand that carbon monoxide and hydrogen, when they are heated at 573 to 673 Kelvin at 200 to 300 atmospheric pressure in the presence of zinc oxide, chromium oxide catalyst, it gives us the methanol. Let us study the various physical properties of methanol. Methanol is a colorless liquid, highly poisonous in nature. Ingestion of small quantity of methanol can cause blindness, and large quantity can cause death. Methanol is used as a solvent in, now these are the uses of methanol. You can consider them as a uses of methanol. So how methanol is used? Methanol is used as a solvent in paints, varnishes, and chiefly for making the formaldehyde. So these are the various physical properties, method of preparation, and uses of the methanols. Now, my dear students, we are going to study about the ethanol. Ethanol is commercially obtained by the fermentation of molasses. So the sugar present in the molasses turns into glucose and fructose. The enzyme present during this reaction is known as the invertase. So we have molasses, C12H